All right, this is a video for geometry on the polygon angle sum theorems. We'll start off with an introduction and do a few solved examples. The polygon angle sum theorem is super useful. It allows us to find not necessarily the individual angles in a polygon, but what those angles add up to, what they sum to for a polygon with any number of sides. And I'm going to give you a formula, but I'm going to try to show you a way of remembering that formula. So the sum of the angles in a polygon is n minus 2 in parentheses times 180, where n is the number of sides. Okay, you could apply this to a triangle. 3 minus 2 times 180 gives us an answer of 180, which we all know is the sum of the angles in a triangle. But let me try to show you why that works. I have an arbitrary pentagon here, okay? And let's pick one particular vertex, and I'm going to draw diagonals to every other vertex in the triangle that isn't consecutive, okay? So I'm not going to draw this diagonal over to here because that just overlays a side. So I drew 2 diagonals and I create 3 triangles, okay? Each triangle has a sum of 180 degrees, okay? And I think you can tell that if we think about all the angles in these 3 triangles, they effectively overlap to create the 5 angles, not overlap, but add together to create the 5 angles in the actual pentagon, okay? And so where does the n minus 2 come from? Well, we were able to draw 2 fewer triangles than there are sides in the polygon. 5 sides in this polygon, we could draw 3 triangles. And 3 times 180 gives us the sum of 540 for the angles in a pentagon. So let's go ahead and apply this real quick. But first we'll do a couple definitions. And I'm not going to write down all these definitions. I'll just sort of speak you through them. An equilateral polygon equals sides. So we have any particular polygon that has all sides congruent. An equiangular polygon has equal angles. All angles are congruent. So for this example, all 4 of those angles are congruent, and they would end up being right angles in this case. A regular polygon is both equilateral and equiangular. So for this regular hexagon, all 6 interior angles would be congruent to each other, and all 6 sides would also be congruent. Okay, so an equilateral triangle is regular, a square is a regular polygon, and there certainly could be a regular pentagon, regular hexagon, etc. Let's do this. Find the angle sum of a heptagon. And I'm actually going to try to draw an arbitrary heptagon that's concave. 3, 4, 5, 6, 7, maybe that right there, okay? To try to show you that the process we were working with actually applies here as well, okay? So we can divide this pentagon, or this heptagon, excuse me, up into a certain number of triangles. Let's pick that vertex right there. And we want to try to draw all the triangles just from that one vertex. Okay, so we have 1, 2, 3, 4, 5 triangles. Each triangle has a sum of 180 degrees. So the sum of the angles in that heptagon would be 900 degrees. Okay. Again, it doesn't tell us about the individual angles. It just tells us that the sum would be 900. But here, if we have a little bit more information, we can do some work with this. We have 1, 2, 3, 4, 5 sides, so we're dealing with a pentagon. So the sum is 5 minus 2 times 180, so we have a sum of 540 degrees. And let's say we're looking for the measure of angle y. We'll call that y degrees. So we can write out an algebraic equation. 90 plus 110 plus 120 plus 150 plus y has to equal 540. So let's combine all those together. So we have 470 plus y is 540. And we can just subtract 470 from both sides, and we'll get y is equal to 70 degrees. All right, key thing there, just knowing that the sum of the angles in a pentagon is 540. Next theorem we're going to look at is called the Polygon exterior angle sum theorem. So if you have any arbitrary polygon of any number of sides and you extended each side at each vertex in one direction, you create an image that looks like this. And then we can think about what all these angles add up to. So those are our exterior angles. And the sum of the exterior angles is 360 degrees. And this is kind of mind-blowing to me. It doesn't matter how many sides we're working with. It doesn't have to be a regular polygon. It could be any sort of polygon that you can imagine. And the sum of the exterior angles will always be 360. So let's do this one, and let's find a missing angle. Okay, so let's find angle x. So this is a hexagon, and what that means is there would be 6 congruent angle x's if we were to build exterior angles all the way around this pentagon, or a hexagon. Okay, so that tells us that 6x is 360. So x is 60 degrees. So that's a 60-degree angle right there. All right, so that's using the exterior angle sum theorem, just knowing that all of the angles, all of the exterior angles sum to 360. And in this particular example, we also knew that all the exterior angles were congruent because we were dealing with a regular hexagon. All right, we did it. We got through it, and that's a great place to stop.